would love to have a large, powerful cabinet saw in my tool arsenal, but my shop space is just too limited for a permanent fixture like that. To fill the void, I've had a 10-inch yellow contractor saw that has, for all intents and purposes, served me well. One thing about that saw that has always bothered me is the fact that I can't use a Dado blade set. The Arbor is just too short to accommodate a stacked blade safely. Of course, Dados can certainly be cut using a single blade and several passes, but the time can add up if many Dados are needed. After some investigation, I found a few references on YouTube and elsewhere about swapping the original Arbor with a part originally designed for a different saw model. Intrigued by the potential of being able to use a real Dado set with my saw, I figured, let's give it a try. It goes without saying, but I'll say it anyway. Step 1, unplug the saw. Because I need to remove the motor, the blade will have to come off. I keep my saw mounted on a portable platform. Just a couple of clips unlocks the saw from the base and allows me to flip it over. First thing to come off is the sawdust shield, which is held on by 4 wing nuts. Next, remove the 2 screws from the riving knife mount. You'll need a 4mm hex driver. Using the same driver, remove the 2 screws that secure the blade height mechanism to the blade well. It's a bit easier to get to these parts if you tilt the saw to the 45-degree position. Removing this plastic cover makes the motor removal easier. Before starting on the motor fasteners, I disassembled the power switch so I could free the motor power cable from the rest of the unit. Finally, I removed the 3 screws holding the height adjustment rails, as well as the motor, from the blade well. With all fasteners removed, the motor easily lifts out. With the motor on the bench, the Arbor replacement starts by removing the 3 screws on the Arbor mounting plate. Sometimes proper tools are not always necessary to complete a task, but I strongly feel this is not one of those times. To separate the Arbor from the motor, I highly recommend not prying with a screwdriver. Things that are press-fit like housings and bearings should not be separated by prying or pounding with a hammer. The better method is to use some sort of puller that provides a constant, even pulling force. I didn't have a puller that would adequately fit this particular case, so I made one out of a piece of scrap 3/8-inch steel bar. It consists of a 5/8-inch center hole along with 2 tapped 3/8-inch holes, which I made using my new tapping machine. The aluminum standoff cylinders were just some offcuts I had laying around. By applying a few turns alternately to each bolt, you can see how easy it is to pull the housing from the motor. With the Arbor assembly out, I covered the motor housing to keep anything from dropping into the grease and set it aside. The Arbor assembly is made up of the Arbor, a driving gear, and 2 bearings. Although I have a replacement set, my goal was to be able to reuse the bearings, and the way to do that is to pull, not drive, the bearings off of the arbor shaft. I'll leave links to all the parts needed for this upgrade as well as the tools I've used in the description below. After a quick examination and giving it some thought, it seemed my best chance was using the drive gear to pull the top bearing. It appears that will place almost no stress on the outer bearing race and subsequently save the bearing. This puller uses the same principle as the one I made. It provides an even, steady pull and makes easy work out of removing the top bearing. At this point, it's important to note the direction of the gear teeth. If installed incorrectly, the teeth will not mesh with the spline on the motor. Also of note, do not lose the arbor key. It'll be needed for the new arbor. With the bearing out, I couldn't feel any grittiness, catching, or slop. The action was smooth and consistent. I'd say this bearing is good. Next, remove the retaining ring that locks the arbor behind the large bearing. If you plan to replace the large bearing, remove the second retaining ring. It turns out I didn't actually need to remove this one, as I was able to save the bearing. Next task is to remove the housing from the arbor shaft. I had a puller that would fit this one. There's definitely more stress put on the outer race of the bearing during this procedure, but again, the consistent, even pull as opposed to the shock of a hammer blow gives a much better chance of saving the bearing. A comparison of the old versus the new arbor shows them to be an exact duplicate. The only difference is the longer mounting lug as well as the coarse thread, so you'll not be able to reuse the blade nut. Again, the bearing felt very smooth with no discernible play, so I felt comfortable reusing it. With the second snap ring back in position and an arbor that I left in the freezer overnight, I used an 11/16" deep socket to only push the inner bearing race, and with a little help of the vise, seated the arbor into the bearing. Freezing the arbor shrinks the shaft ever so slightly and reduces the force necessary to seat the bearings. Next, reinstall the smaller snap ring to secure the arbor in place. If you freeze the arbor, I recommend freezing the key as well. I overlooked this step, and fitting the key into the keyway was a bit of a challenge and took a little bit of persuading. Reseat the gear, making certain to orient the teeth in the correct direction and press it home using the same 11/16 deep socket. Pay close attention here, making absolutely certain the gear is not askew when you begin to press. The gear channel or the shaft surface can easily be marred if you force the wrong fit. Take your time and do it right. For the smaller bearing, I used a 7/16" deep socket on the inner race to seat it in place. The grease inside the housing still looked pretty good, so I spread it on the gear and then wiped it clear of the bearing mating surfaces. With everything cleaned up, the Arbor assembly is reinstalled in the motor housing, making sure the gear teeth mesh up and engage properly. Applying a few turns at a time, I worked my way around the Arbor mounting flange, seating the assembly in place. One final spin to ensure everything is moving freely, and it's time to reinstall the motor. I used a little Loctite on all the screws that mount the motor to the blade housing. I'd rather not have those vibrate loose when the saw is in use. First, fit the height adjustment rails to the appropriate holes in the motor mount. Note the difference in the two rails. The one with holes at both ends goes to the right. It takes a little adjusting, but once lined up, install the 3 screws, but don't dog them down all the way yet. Line up the blade height lifting block with the 2 holes in the blade plate and reinstall the 2 cap head screws. I used some Loctite on these as well. Now go back and tighten down all 3 mounting screws. Next, reinstall the switch. While I had the saw apart, I added a soft start circuit to the saw so that startup isn't quite as violent. To keep this video on subject and as short as possible, I'll cover that topic in a future video that will be linked here when it's complete. For now, just install the leads from the saw back into the box and reconnect the leads to the same lugs they were removed from. Basically, the black and white leads from the mains go to the bottom 2 lugs, and the saw leads connect to the top 2 lugs, making sure black lines up with black and white lines up with white. Reinstall the plastic cover and check to make sure the height adjustment works smoothly. Next, reinstall the riving knife mount. Now we run into a problem. Because the Arbor is now longer than it used to be, it interferes with the sawdust shield, not allowing it to lie flat. I need to make some sort of gasket to offset the shield and allow it to clear the Arbor. In Fusion, I bring in a photo of the sawdust shield and I used it to model a gasket. This is a very quick overview of the process, but the end result is a model I could send to the 3D printer. The first gasket I made is about 15 millimeters or about a half an inch deep, which meant I needed to replace the short wing nuts with some 25 millimeter M5 screws. In the slicer, I had to cut the model in half in order for it to fit my printer bed, but a little cyanoacrylate made it whole again. I fitted the plate to the saw, flipped it over, and started the process of truing up the blade when I ran into a hiccup. I was not able to bring the blade all the way to the 45-degree position. Upon closer inspection, I realized the sawdust shield was hitting the bottom of the saw deck. No big deal, a quick jump back into Fusion to reduce the depth of the gasket to about 1/4 of an inch or 6.5 millimeters. Reprinted, glued up, and installed. I did have to change the screws from 25 to 15 millimeter M5s. Back at the saw, I set up my stops for 0 and 45 degrees. I had a hard time getting it exact, but was within 1 degree of tolerance, which is fine for now. Hopefully all this effort speeds up the process of cutting dados. Let's see. Once again, I'm very pleased with how this project turned out. The dado set is safe to use, quick, and accurate. There's a bit of tear out with my current setup, but it's nothing that a zero clearance blade insert couldn't fix. If you're interested in modifying your saw, I'll leave all the relevant information on part numbers and required tools in the description below. If the video was helpful or entertaining, please strike a like and leave a comment. Not only does that help get the video out to more great folks like you, it also gives me a chance to interact with you, which I really enjoy. Until next time, I'm mainejason. Get out there and give it a try.